Hello everybody, welcome back to another video about Algebra 2. So today we will be talking about permutation, and this is going to be the next part where previously we talked about the two counting principle. So you can think of permutation as kind of like a way of doing a two counting principle with a certain restriction. So first what we'll do is we'll define what a permutation is, so then we can go from there. A permutation is an arrangement of some or all of the elements from a given set in a definite order. So for those of you guys that are not really, like math people, let me see if I can try to break it down for you so that it'll be more of an English thing that you can understand. How many different ways can you select 4 boys out of 10 to make a band where there is a drummer, a singer, a guitarist, and the last one to stand out to look pretty? So in the previous video, we talked about the two order of arrangement where we're either going to multiply the number of elements or we're going to take the number of elements and we're going to add them. So here, according to the last video, what we can do is the following. We can create 4 events over here, okay? And the reason why there are 4 events is, well, you're doing 4 things. You're creating a drummer, and let me go ahead and get that ink ready. Okay, you're creating a drummer. Oh, where's my pen? Oh, there's. Okay, you are not happening. Oh, this is not. Okay, there it is. Okay, so you are creating, as I was saying, a drummer over here. You are creating a singer. You are creating a guitarist, and you are creating the last person in there to stand there to look pretty. So that's why there are 4 events, and I want all of them to happen all together. So that tells me, according to the two counting principle from last time, we're going to multiply all these numbers together. Now, there was one example that I did in the last video where we said, okay, well, let's go ahead and go down the list and see what happens. If I were to first pick the drummer, there are going to be 10 guys to choose from. So that means that that number is going to be 10. Now, the next person to choose from has to be a singer, and the drummer cannot be the same as the singer because, well, there's one specific role for each specific person. So what that means is you no longer have 10 boys to select from, but instead you have 9 boys to select from. So in this case, you can see how it's 1 less from before, and that was the example that I showed in the last video. Then you have to choose a guitarist, so that means it's going to be 1 less as well, so you multiply by 8. And then 1 less of that, so then that last person is going to be just going to stand there and look pretty. And so there are now 7 guys left to select from, so the answer is going to be 7 over there. The final total number of ways to do this will be all of these guys multiply out together. So that's 10 times 9 times 8 times 7 then, and that's going to be our answer. So whatever that comes out to be, which is probably going to be a pretty large number. And in fact, you know what? We might as well go ahead and solve for that right now, right? Just to make sure. So 10 times 9 times 8 times 7. So the answer looks like 5,040. So let me go ahead and put that in right there. Okay, so it's equal to 5,040 ways, different ways. Okay. Now I want you to consider my answer over here that we got, which allows, I want you to consider the numerical values that we got to get to the answer. 10 times 9 times 8 times 7. To some of you guys, and hopefully to all of you guys, this will look somewhat familiar because you'll notice that it's almost like a factorial, right? So let me go ahead and write that out in a form that might be a little bit more familiar to you in a factorial form. This kind of looks like a 10 factorial in a way because you have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But the problem is, well, you don't have the 6 factorial part. So to compensate for it, I'm going to go ahead and say divide by 6 factorial. And that's what this number is over here. Okay, and if you don't remember the factorial part of this, well, you might want to go back and take a look at it just in case then. So that is going to be how we get our answer for this one. And one notation that some people like to write in this case is the following: 10p4. Okay, because you have 10 to select from, and you're going to select 4 out of the 10 in order to get the result. So that is going to be equal to this 10 factorial over 6 factorial. This is how we got our answer. Now, let's look at our second example just to kind of solidify all of this. In a 16-man pot of Pokemon tournament, how many ways are there to select a first place winner, second place winner, and a third place winner? Now, first, I'm going to go ahead and write it in this NPR form, so then that way you can see how the numbers are set up. What I'm trying to solve for first is supposed to be the following. 16P3, because what's happening is I have 16 people in a tournament and I'm going to select 3 of them to be one being the first place, second place, and then finally the third place. Okay, so once again, going back to our formal definition, right? This is exactly what's happening. I'm basically taking an arrangement of some or all of these elements, which in this case, the elements are the people in the tournament, from a given set in a definite order. And the definite order is basically saying that, hey, one has to be doing something, one has to be doing something else, and the last person has to be doing something else different from the first two. Okay, so they're all selected with a certain order to this. Okay, so now let's talk about how we're going to solve for this one then. Well, if you're looking at the top part, then it's kind of the same idea. We have a first place, we have a second place, we have a third place. So that tells me it's going to be 3 numbers, and they're all going to be multiplied by each other because we have 3 different events and we want them to all to occur. So again, it's the 2 counting principle where we're going to be multiplying. In the first place, there are basically, if we were to just kind of like go down the scale, if you're going to choose the first place first, well, there are 16 to select from. And then after that, you're going to select the second place, and then there's going to be 15 left. And then after that, you're going to choose the third place, and then there's going to be 14 left. And it really doesn't matter the order you go. I mean, like, regardless of how you pick the in this case, you could pick the third place first, second place first, or third and first place last. You're still going to get 16 times 15 times 14. So that part, it doesn't matter. But what is important is that this, again, this is a factorial notation, just like the problem above. So this, to me, looks like a piece of 16 factorial, missing everything that is 13, 12, 11, and 10, and 9, and all that below. So what that means is you're missing the 13 factorial part. So if you're missing the part that's there, then we're going to go ahead and divide by that 13 factorial. So you can see how that actually works out, just in case. That's 16 times 15 times 14 times 13 times 12 times 11 times ... all the way to 3 times 2 times 1. Whereas the bottom guy is going to be 13 times 12 times 11 times ... times 3 times 2 times 1. And you can see how, as I said, the 13 factorial cancels with both top and bottom, which then represents what we got then. So the numerical answer, again, just for those of you guys that are kind of curious. So we're going to take 16 times 15 times 14. So the answer is equal to 3360. So we're going to go ahead and put that in here. So this is equal to 3360 different ways then. Okay, so that's going to be our answer. Different ways. Now there is a permutation notation in your calculator, meaning like you can actually put this in your calculator or this in your calculator, and it will automatically solve for that for you instead of having you to plug in all of this. So let me just kind of show you where it is for those of you guys that are interested. So the way it works is in the previous example, I asked for what is 16p3. So you're going to plug in 16, and then it's usually under math. And then if you go to probability and you see NPR, that's basically what we're choosing from. Oh, sorry, 16 goes on the bottom right here. And then let me go ahead and delete these two guys right here. And then we're going to go ahead and put the 3 right there and cross my fingers. Yeah, exactly the same answer. So yeah, so it's there. You just have to kind of look for it in your calculator then, okay? All right, so let's kind of conclude with a formula that we can actually use then. So let's say that I have n number of elements being, like these things that we're choosing from. So in this case, maybe the number of men, number of boys, whatever you have. And then we're trying to create these small little subsets of groups where the order actually matters. So that's why we call P for permutation. And the number of subsets that we want to create would be R number. Okay, so NPR. According to what we've been doing so far, it looks like it's going to be 1 factorial divided by the other factorial. The numerator's factorial is going to be n factorial in this case, looking at the 2 examples that I just gave you. Whereas the denominator, the factorial there, is going to be the difference between the 2 values. So it's going to be n minus r factorial. Okay? So, just another example on the side. Let's say I want to solve for what is going to be 8p6 then. So another way of saying that would be if you have 8 elements, how many different ways are there to select 6 different elements to assign to each one to do a different thing? So the way you're going to be solving for that will be 8 factorial divided by 8 minus 6 factorial, which is the same thing as 8 factorial over 2 factorial. Okay. All right. So remember, key thing is that you're creating subgroups when you're doing these permutation problems, and these subgroups, they have to have a definite order, meaning the order actually matters in the subgroup. If the order does not matter in the subgroup, meaning that you're just picking subgroups in general, well, that's going to be a different thing. That's going to be for next time when we talk about it then, okay, in section 12.5. All right, so here we go. Let's look at some examples that you might encounter then, okay? Here we have the following. In a 5-letter arrangement, the word gravy, gravy in this case, I guess, how many ways can you do the following? Create a 3-letter arrangement, okay? So what I'm trying to say is with the 5 letters that you have right there, G, R, A, V, and Y, I would like for you to create a 3-letter quote unquote words because I want an arrangement in this case. And it doesn't necessarily have to be an actual word. It's just an arrangement of letters. So for example, V, A, R would be an arrangement. G, R, A would be an arrangement. R, V, G would be an arrangement, and so on and so on and so on. Okay, so I want to know how many ways can you create these 3-letter arrangements then? Well, going by what we said so far, this is exactly the same idea as what we've been doing. So this is going to fall into the permutation category because we have 5 letters, 5 elements in this case, and I'm going to select 3 of them where the order of those 3 letters are going to matter. So then that means what I'm trying to solve for, according to what we said so far, is 5p3. So the answer is going to be 5 factorial over 5 minus 3 factorial, which is the same thing as 5 factorial over 2 factorial. So that gives me 5 times 4 times 3. So you look at the 5 times 4 times 3, I think for most of you guys, that would make a lot more sense because if you look at our previous examples, right, that's basically what we did. We have 3 unique events that I want to occur. And for each one of those events, I'm going to select a letter without replacements. And I actually need to say that for all of these without replacements then. So nonetheless, that's going to be our answer then. So 5 times 4 times 3. So the answer is equal to, help me out here, that's going to be 60 in this case. Okay. Okay. Let me go ahead and change the problem right here just so that it matches with what we've been doing so far. Without replacement. Okay, because if I didn't actually have that in there, the problem would actually be a little bit different than what we've been doing so far. Okay. Okay. Now let's go ahead and move to the next one and see if we can do the same thing. Okay. This time I want to create a 4-letter arrangement that starts with the letter A. So for those of you guys that want to see it using these slots over here that I've been doing so far, let's do it that way first, okay? Because I want to show you 2 different variations, and you decide which one works best for you. So I see it as a 4 event thing. I see it as something that has 4 events because I have 4 letters to choose from. I want to make sure that the first letter is going to be A. Now, we have to think about what is the most restricting first, take care of that, and then afterward deal with the rest of it. Because if we do it the other order, if we just do it in any order, the problem would then be wrong. Okay, so my first letter has to be A. So that means that I look at now my the letters that I have to choose from, Gravy. How many A's are there? There's only one A. So to me, that's going to be 1 over here because there's only one A available. Now, for the other 3 letters, you still have to choose them, and they actually have to. They still have a role to play. Okay, so when you now choose the second letter, well, how many letters are there left to choose from? A is already chosen, and remember, there's going to be no replacement, so that means you can't choose A again. So there are a total of 4 letters left because there's G, R, V, and Y. So that second one is going to be a 4. Times the next one after that, you chose A already, you chose one of the other letters, you're going to choose one more after that. So instead of 4, well, now it's going to be 1 less, which is 3. And I think for the second part, you'll probably get that idea, which is going to be 2 because it's 1 less than the 3 then. So taking all those numbers and you multiply it all out together, that's going to be your answer. So this looks like to me 4 times 3 times 2, which is equal to 24. Okay, so that's one way of seeing it. Now, in terms of how do you show it with these P thing, right, the permutation notation, we can do that too. So again, you choose whichever method you want best. So here's how I'm seeing it. Remember, the first arrangement, right? We said that you have to have the letter A. So to me, that's like saying out of the one letter A that we have, I am going to select that letter A. So it's 1P1. Multiply by. Now we have to worry about the other 4. Now we have to worry about the other 3 letters out of the 4 in the 4-letter arrangement. There are 4 letters left, and I am going to select 3 of them in order to create that 3-letter arrangement after I create the A. So it's going to be 1P1 multiplied by 4P3. And if you multiply that out, that is going to give you the 24 just as well. Okay, so some people like to see using slots because that's a little bit more effective for them. Some people like seeing the NPR notation, and that's totally fine. You pick your, you take a pick of whichever one works best for you. Okay. All right, next one. Create a 4-letter arrangement that starts with a consonant. So we'll just go ahead and do both ways so you can see how it all works out. So again, we have a 4-letter arrangement. So that means there are 4 events that I want to happen all at once. The first letter has to be a consonant. Well, how many consonants are there? There are a total of 4 of them. So that means we have 4 to select from. Now, the second letter that you choose, there's no restriction afterwards, but you just can't use the previous one. So in the previous case, I have 4 letters to choose from. There are 5 letters, but then remember, you use one for the first letter. And now you have 1 less for the second letter. So what that means is for the second case, there's going to be 4 as well, because remember what we just said, you just used 1 up. Then you're going to choose 1 more afterwards, which is 3. 1 more afterward, which is 2. The third, the second, and the 4th letter doesn't matter that it's a consonant so long as you choose some sort of letter. So that's why it's 4 times 3 times 2. And again, the first one, well, it's a 4 because there are 4 consonants to choose from. So that is going to be our answer. So let's see what that comes out to be. That is going to be equal to 16 multiplied by 6, which is equal to 96 then. That's the answer. In a permutation format, just again so you can see it from a different perspective, we have to first select the first letter. That's going to be a consonant. Remember what we said. Out of the 4 consonants that we have, we're going to go ahead and select one of them for the first letter. So that's why it's 4P1. That right there is the same as this 4 over here. Then we're going to also have to select the other 3 letters. There are 4 letters left, and I'm now going to select 3 of them. So that part right there, that's going to represent these parts right here. Okay, so take these 2 guys, multiply together, and that'll give you the 96 as well. Okay. Let's see. Let's look at part D then. Create a four-letter arrangement that starts with a letter A or a consonant. Okay. Now think back to what we just said in part B and part C, right? Part B, I want all the arrangement that starts with the letter A. Part C, I want all the arrangements that starts with a consonant. Part D says that I want one or the other. According to our two counting principle, then that means that I'm supposed to add the two answers from part B and part C together. So the answer would then be 24 plus 96. So that right there is going to come out to be 120 then as our answer. Okay. Another way of thinking about this problem, if you kind of notice already, is that, hey, you know what? Let's look at this as a whole. I'm picking 4 letters, right, to begin with. And my restriction here is that the first letter is an A or a consonant. Well, let's take care of that first because that's going to be our most restriction. If you're picking an A or a consonant, then that means that it could be any one of the 5 letters because, well, it's basically 5 out of 5. You can pick anything. So to me, that's going to be the 5 right there. Then afterwards, we have to choose the other parts. The second letter, you have 4 letters left to pick from. So that's 4 times 3 times 2. So note that this, when you multiply it out, then that would actually give you the same answer in this case. Okay. I guess if you were to write this as a permutation notation, the way I see it is that, again, it's just going to be part B plus part C. So this is going to be 1P1 times 4P3 plus 4P1 times 4P3. Okay. Let's see. In the perspective of this, I guess these little 5 times 4 times 3 times 2 event notations. The first one, the 5 right here, you have 5 letters to pick from, and you are going to go ahead and select one of them. So that's 5P1. And then for the last 3 letters out of the 4, same idea. It's going to be 4 letters left, and you're going to go ahead and select 3 of them. So that's 4P3. So again, you know, you pick whichever version you like best then. Okay, final one. If you select 3 letters from to form an arrangement, again, keep in mind we have different arrangements in this case with no replacements. What is the probability that the arrangement contains only consonants? Okay, only consonants. Okay, so here, let's go ahead and create the slot so you can see what's happening here. So you have 3 slots because you have a 3-letter arrangement. Okay. Now the slots, I am going to have to do a little bit more than what we've been doing so far, because if I'm looking for the probability, then that means that the answer should be some sort of value between 0 and 1. That is most likely going to be a fraction in this case. So what I'm saying is there's going to be a numerator and then there's going to be a denominator. The numerator is all the possible ways that will give me what I want, divided by the denominator, which will give, which is supposed to represent all the possible ways of setting this, all the possible events that are out there. Okay. So here, let me just kind of write it out. So P of X is supposed to be the number of events, okay, wanted, divided by the total number of events, total. Okay. So let's go ahead and see how this works out here then. The first event, I want, well, let's just kind of go down the list. In the first event, I want it to be a consonant. Well, let me just write that over here. We have G, R, A, V, Y. I see 4 consonants that I can choose from. So that means the first event is going to be a 4. Then your second event, right, you're still going to make sure that it is going to be a consonant, but now there are only 3 consonants to choose from. Yes, technically there are 4 letters that are left, but remember, you still have that restriction of making sure that all the letters are supposed to be consonants, and that's why it's 3 and not 4. So it's going to be multiplied by 3. Then afterwards, you're going to choose your last letter, which also has to be a consonant. You chose 2 already, so that means there are 2 left. So that is going to be 2 over here. Now, that's going to be the total number of events. So if I multiply that out, that would normally answer what I've been asking for so far. But I want to now find out what the probability of that happening is. So that means I need to divide by the total number of events. Basically, the total number of arrangements that we can have with these 3 letters out of the 5. Well, going by what we said, we have 5 letters to choose from, and I'm going to go ahead and select 3. So the bottom is going to be 5 because there are 5 letters to choose from. Then after that, you're going to have only 4 letters left to choose from because you selected 1 already. And then after that, you're going to have 1 less, which is 3 to choose from because, again, you selected 1 already. So with all of these multiplied together, that would then give me the probability of what I want then. So let's see, the 3's would cancel out, the 4's would cancel out. So this is going to give me, looks like it's going to be 2/5 as our answer, or we can say 40%. Once again, let's go ahead and show it from the permutation perspective. So then that way you can be, satisfied with this also. The numerator, here's how I see it. You have 4 letters that you want to choose from because there are 4 consonants. So out of the 4 letters, I'm going to go ahead and select 3 of them. So 4P3 divided by, well, that's the total number of events in this case. There are 5 letters to choose from out of all the entire events, and I'm going to select 3 of them. So right there, that notation right there, that should give you what's on the left-hand side. And again, that would then give you the 40 degrees. The 40%. All right, so thank you again for watching. I will see you next time, and hopefully this